we'll get started. All right. Exponential and logarithmic equations and applications. So our objectives today are to solve exponential and log equations and to solve problems that can be modeled by the exponential log equations. Okay? So the exponent property of equality, and you're going to see this as you got into WebAssign. It was probably what number was it? Were you 13? What you can do is when you get your bases the same, you can drop them and just set the exponents to each other. So let's look at a couple examples here of 3x or 3 to the x equals 9. Well, isn't 9 3 squared? So you got two ways to approach a problem like this. Before today, you don't need to write this down. Before today, you would have wrote it as log base 3 of 9 equals x. And you all would have thought to yourselves, 3 to what power gives me 9, guys? What's our answer? 2. Okay? But today, you also could think of it like this. Isn't 3 to the x equal to, isn't 9 3 squared? And when your bases are the same, you can set your exponents equal to each other. X equals 2. Okay? Now, this one, I don't think I would have rewrote it in log form. So let's try this. We're getting the base the same. What we got a common base of 125 and 25, guys. What would it be? What's a common base that they both would have in them? 5, wouldn't it be 5? 5 to what power gives me 125, guys? 5 to the 5? 5 to the 3, because 5 times 5 is 25, times 5 is 125. So 5 cubed raised to the x equals 5 to what power gives me 25? 5 squared. And then don't forget raised to the x minus 2. Now we're almost there. I recommend when you have a power raised to a power, before you drop the bases, let's get these exponents written a little bit more properly. 3 raised to the x power is 3x, isn't it? Don't we multiply the exponents? And then equals 5 raised to the... Make sure you do what? What do we need to make sure? So would it be 2x minus 2? No, we got to distribute this 2 through. So it would be 2x minus 4. And if our bases are the same, we can drop them. And now we have 3x equals, what is it, 2x minus 4? Subtract 2x, x equals negative 4. I just want to point out to you again that this x goes into an exponent. We're allowed to have negative exponents, so we're good. Questions? All right. Obviously I can't break 3 down any further. 3 is going to stay 3. So it's 3 raised to the x squared plus 4x. But 1 over 81, that can be rewritten as 3 to the what? Austin, 3 to the what power? Very good. 3 to the negative 4. And now I can drop those bases, and I can set x squared plus 4x equal to negative 4. I'm going to subtract over... Because I have a quadratic equation, if it's quadratic, I want it equal to 0. And I think, doesn't x squared plus 4x plus 4, doesn't that factor in x plus 2, x plus 2? Or x plus 2 quantity squared, either way it works. So we're going to get x equals negative 2. Okay? We okay with it? All right, easy enough. Okay? All right, but look at this one. 5 and 9. This is different than my first three examples. How? Caitlin?
Bases aren't the same.
Yeah, you're not going to be able to manipulate 5 and 9 to get the same base. So here's what you're going to hear me say over and over. I can't solve it in exponential form. I'm not going to be able to get the same base. I can't solve it in exponential. If you can't solve it in exponential, rewrite it in log. So what would it be in log form? Ms. Rice, what would that? This would become what in log form, hon?
Log base x.
Ooh, careful.
Or 5.
Yeah, your base is 5. So log base 5 of
9
equals,
x.
and guys, grab your calculators. You all can get this for me, can't you? Log base 5 of 9. It's going to be 1 point something. Let's go 3 decimal places. Log base 5 of 9. Maya, what'd you get, hun?
1.365.
1.365. Do I have an agreement on that? Yeah? Very good. Thank you, Maya. We good with that? So if you can't solve it in one form, rewrite it in the other. So look at this one again. This one gets people. They think, oh, yeah, 12 and 3 are going to get the same base because 3 times 4 is 12. Well, but remember, we're thinking in terms of exponents. 3 squared is 9, times 3 is 12. We're never going to get to the same place. Y'all with me on that? With breaking it down further. So you can't solve it in exponential. Do what, guys? Rewrite it in log. So we're going to rewrite it as log base 3 of 12 equals x plus 2. So let's get that in our calculator. Log base 3 of 12. Okay. Moxie, what'd you get for log base 3 of 12?
I can't figure out to log base 3. My calculator, I don't know how. Forgot.
Well, remember you could have went log of 12 divided by log of 3. Remember that as if you can't remember it. But also I think it was what under math?
Yeah.
Math A?
There's no A for my math.
Okay, so you need to then you need to do it the old school. Log of 12 divided by log of 3. Okay? Amanda, what'd you get for that? 3 to what power gives me 12? 2 point something. Okay, but look what I'm going to do here. 2 point squiggle equals x plus 2. You do not, listen to me, you do not round until the final answer. Is that all clear? So it's 2 point something. Then what do we do to get x by itself? We do what? Subtract 2. So now subtract 2. Now I know it's still going to be the same thing because there was no decimal, but you have to be careful. Then our final answer then would be, Amanda, point.
0.262.
Do I have a confirmation on that? 0.262. Good. We doing okay? All right, let's keep it rolling. All right. Even a little bit more complicated one. Because look, you have multiple exponents. And obviously 5 and 3 are not going to get the same base. So I can't solve an exponential. I need to rewrite it in log. Okay, I'm going to look. Follow my cursor here. I'm going to treat 5 as the log. So I'm going to rewrite it in log form. Log base 5 of, since I'm calling this the base, that's my exponent. So log base 5 of this, 3 raised to the 2x, equals 5's exponent, which was what? What was 5's exponent? X plus 3. Everybody see how I denoted this was my base. You could have done this way. You would have been right also. Log base 5 of this, 3 raised to 2x equals x plus 3. Now, let's use our properties of logs that we learned last class. What can I do from here? You're going to use some property logs. Want to try it, Caitlin?
Move the 2x in front.
She's right. Let's move this 2x out in front. So now it's 2x times the log base 5 of 3 equals x plus 3. That was the correct first step. Why does that help us? Somebody else tell me what to do next. Why did that help me? Matul?
Could we not divide 2x?
Nope, you don't, not yet. Not yet. Go ahead, say it louder, Caitlin.
You can solve log base 5 of 3.
That's right. Guys, look right here. Can't you get this? Can't you go to your calculator and get log base 5 of 3? Get it. Get log base 5 of 3. And log base 5 of 3 is what? 0.6826. But hold on, we're not going to write it down yet. Okay? So I'll write it down. You just keep it there. It's 2x. And then that became what? 0.68, blah, 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 squiggles. Why'd I squiggle it? Because I'm going to do what now? I'm going to take this times 2. So take that times 2. Now you have 1.36 squiggles x equals x plus 3. Now I have x's on both sides. How about we subtract 1x? So let's subtract 1x, which means you're going to do what? You're going to take your answer and subtract 1. And now you have 0.36 squiggles x, don't forget the x, equals 3. And now what are we going to do to get x by itself? Kyle? By? Divide by 0.36 squiggles, whatever it is in your calculator. So you're going to take 3 divided by that. Do not type it in. Recall it. It's 3 divided by it. Get clear, Ella. 3 divided by that. Second negative recalls the previous answer. I'm sure it's a special service student. What do we get then? X equals, Ella, what do we get? Because I've been watching it. You've been dominating it. 8 point, say it.
214.
8.214. Does that sound right, guys? Okay, let me make sure we're clear on how we do that on our calculator. Make sure we have this. Guys, look up here. We went log, whoop, I messed up. Math is A, right? Yours is not there, Moxie? You need to reset your memory. Log base 5 of 3, right? Then what'd I do? What'd you guys do? You multiplied it by 2. Then what? Subtracted 1. And then you went 3 divided by, follow my cursor, the previous answer to get that. Don't type in. Recall it. Okay? Make sure we're clear on that. You good? Okay. Now we're going to talk about the log property of equality. If we have the logs of the same base, the same, we're going to drop them like it's hot. So we're going to think Snoop Dogg, go gangster, and we're going to drop it like it's hot. Okay? So I played the song yesterday, and then I forgot how inappropriate the song, like it was not the edited version, and so I'm recording, and we're not going to play it. Fair? We're just going to sing it. All right? So let's do one like this. Okay. Can't be dropping things like it's hot yet. So first of all, let's use our log properties. I have a log base 3. plus a log base 3. Can I rewrite the left-hand side as the log base 3? And what do I do, guys? What do I do? Log base 3. What do I do with this x minus 3 and x plus 2? Andrew?
Times it.
You multiply them, don't you? So that becomes log base 3 of x squared minus x minus 6 equals log base 3 of 6, okay? And then when you have log base 3 equal to log base 3, you do what? Drop it like it's hot. Isn't it something like that, right? We drop it like it's hot. See, that was me as gangster as I can get. X squared minus x minus 6 equals 6. And now we have a quadratic equation. So we can subtract it. So now I have what? X squared minus x minus 12 equals 0. That factors, doesn't it? Into x minus 4, x plus 3. So x equals, what is it? 4 and negative 3. And notice I'm not circling it yet. All right. Why? Owen?
Check it.
Okay. How do I check it?
You plug each number back into the original expression.
You gonna work it all the way out?
Uh,
Okay. I'm not.
what do we do?
I know 4 works. Look.
Oh,
Boom. 4 works. Okay, I'm good. Somebody else? So 4 works. Why is negative 3 not work? Has nothing to do with it because it's negative. You're right on what you're saying. Keep saying it.
B can't be 1 or less than 0.
Yeah. So if we graphed, come off this side here. You don't need to draw this. If I said graph a log function, doesn't it look something like that before a shift? What's a domain? All x values greater than 0. Can't equal 0, and obviously it can't be negative. If I plug in negative 3 right here, what's negative 3 minus 3? Negative 6. Remember, log, you can't have a log of a negative value. So negative 3 is an extraneous solution. It's no good. Only x equals 4. Can you follow that? Okay, let's keep it going. So, now, this one, I can't drop logs like it's hot because I don't have a log of a base equal log of a base. I can't solve it in log form. So what should I do, Shayla? If I can't solve it in log form, I should rewrite it in exponential form. So it becomes 2 to the 5th equals x minus 1. Look how basic this problem is now. What 2 to the 5th is what? 32? So I have 32 equals x minus 1. I'll add 1. X equals what, guys? 32. Good. Well, that'd help if I could add, doesn't it? X equals 32 plus 1. Did I even say 33, or did I just say? Okay, my bad. Thank you. There you go. All right. Now, what could x not have been? Yeah, what would have made this log 0? 1. Anything from 1 and less than 1 would not have worked. The domain is all x values greater than 1 on this one. Because think about it. Isn't this a graph of, if we graph this one, wouldn't we have shifted over to the right 1? So our domain would have been x values greater than 1. We're good. We're good. Okay? Okay, I got a log of base 5 of x plus a log base 5 of x plus 4. What do I do? How do I rewrite that? John?
You can multiply the x and x.
Very good. We're going to combine those two logs on the left, and we're going to rewrite this as log base 5 of, let's see, x times x plus 4 would become x squared plus 4x. Y'all agree with me? Equals 1. Can't solve it in log form. Rewrite it in, everybody rewrite it in exponential. 5 to the 1 equals x squared plus 4x. Well, 5 to the 1's 5, so subtract the 5 over. 0 equals x squared plus 4x minus 5. I think that we're going to get this to factor. 0 equals, what's that going to factor into? Ms. Westel, what will that factor into?
X plus 5, x minus 4.
Very good. X plus 5 and x minus 1. So x equals negative 5 and 1. Okay. Which of these is no good? You can't have log of a negative 5. Get rid of it. So x equals 1. Okay. We're getting the hang of it. All right. Let's do a hard one. Harder. But you guys are smart, so harder. Not even hard. Harder. Okay? Combine those logs on the left, so that's going to become log base 6 of x cubed plus 1. Boy, that was horrible penmanship. X cubed plus 1 divided by, what is that, 5x squared plus 2x minus 3. And that still equals 0. Here's what I'm thinking. Okay, think with me. Isn't let's see if this simplifies a little bit first. Sound good? Doesn't x cubed plus 1 factor into x plus 1, right? Times, so listen to me, x plus 1 times x squared minus x plus 1, right? Okay, so I got a question down here. Look up here. Do we have a factor of x plus 1 here? Does that factor? With one of them being, let's see, 5x, x. If I went x plus 1, hey, that worked, didn't it? And remember, we already stated that x cubed plus 1 is x plus 1 times x squared minus x plus 1. Did I do that right? So those x plus 1's cancel. So now I have log base 6 of x squared minus x plus 1 all over 5x minus 3 equals 0. We still good? Questions? Okay, what do I do now? Moxie, what do you think we should do? You have no idea? I can't solve it in log form.
You would write it as log 6 to the power of 0
Okay,
equal to x squared minus
Good.
x plus 1 over 5x minus 3.
good. Okay, I thought you said you had no clue. Why? What is, okay, stop. Is everybody okay with that? Guys, what is 6 to the 0? Okay. And you know what I'm going to do? Look up here. I'm going to cross multiply. What's 5x minus 3 times 1? 5x minus 3. And that's equal to x squared minus x plus 1. I just cross multiplied. And now I'm going to, look up here, I'm going to subtract 5x, and I'm going to add 3. 0 equals x squared minus 6x plus 4. All right, you're going to look and see if it factors. Guess what? It doesn't. So we're going to quit, suck our thumbs, and move on? No, we're going to do what, Anthony? Quadratic what? Quadratic formula. All right, let's go. Here we go. We got this. I'm glad nobody's quitting. We totally got this. X equals negative b, 6 plus or minus. Let's see, what do we get there? B squared 36 minus 4 times a times 36 minus 16. Anybody else get that? All over 2. So 6 plus or minus square root of 20 over 2. And isn't square root of 20 4 times 5? What's square root of 4? 2. Square root of 5 all over 2. And then you can take out a 2 out of all these, so it becomes 3 plus or minus 1 square root of 5 all over 1. Now I'm going to help you out here. I already checked it. 3 plus square root of 5 works obviously for both of them because it's positive. And even though 3 minus square root of 5, it's like, let's see, that's like point. What's, guys, type in your calculator. What's 3 minus square root of 5? 0.7604. If I plug that back through, it's still, both of these values right here are positive. So we have 2 answers. Cool? All right, let's skip one. Skip that one. Can you solve this one? I can't in log form. So rewrite it in exponential. Shirley, what's the base of natural log? Ooh, that's common log. What's the base for natural log? A, B, C, D, what? E, okay, good. E to the what? Second power equals x plus 2. Good. You guys know how to take e squared in your calculators? Get e squared. Whatever it is, then you're going to do what? Then you're going to subtract 2. Right? I love that you're showing me now. Go ahead and read it to me, Ella.
5.389.
5.389. Do I have agreement on that? Thank you. You guys doing okay? All right. Okay. Same thing here. For sake of time, because I want to give you guys a little bit of time to work, and I ran out of time yesterday. I want to talk about this radioactive decay formula. If A is the amount of the radioactive material present in time t, and A naught, that's initial time, A naught, was the amount present at time equals 0. So that's why they call it A naught. There was no time. Time is equal to 0. And H is the material's half-life. Then we get this equation. Okay? So we're talking about half-life. We know certain particles, elements, break, like carbon takes 5,700 years just for half of it to break down. Okay? So it has a long life in it. Okay? So here, let's try this one. The half-life of tritium is 12.4 years. How long will it take for 25% of a sample of tritium to decompose? Okay, let's write that formula for me. It's what? It's A equals the initial value, A naught, times 2 raised to the, is it negative T over H? Negative T over H. Okay? Now, again, H stands for the half-life. So H is the 12.4. Everybody with me? I'm asking for how long will it take for 25% to decompose? I'm looking for T when it takes 25% to decompose. So this is how I tell students to think about it. Doesn't matter how much you start with. You're going to start with 100% of whatever material you have. Y'all with me? So let's just say we have 1 gram. What's 100% of 1 gram? 1. Everybody agree? 100%. How much are we trying to find decomposes? 25% decomposes, which means we have what percent remaining? If we take away 25% of a whole, we have what percent remaining? So what's 75% of 1 gram? 0.75. So here's my initial amount of 100%. 25% decomposes. I now have 75% times 2. I'm looking for t raised to the negative t over, what do I plug in for h again? 12.4, because h is the half-life. Y'all with me? Okay, now, don't do this next step, but I'm showing you. You divide by 1. Would y'all agree that we don't need to take something and divide it by 1? So we really have 0.75 equals 2 raised to the negative t over 12.4. Okay. Well, crap. What do I do? I can't solve it in exponential. You're welcome. So therefore, me tool? No, don't take it. We're not going on a date. Rewrite it in log form. Okay? I'm going to take it somewhere real nice. All right? So log base 2 of 0.75 equals negative t over 12.4. Okay, what do? Go to our calculators. Find log base 2 of 0.75. I'm going over my shoulder here of Ella. She's been guiding directly the whole time. No pressure, Ella. Log base 2 of 0.75. We get negative 0.4 something, right? I'm going to write that. Negative 0.4 squiggle equals negative t over 12.4. I'm solving for t. I then do what, guys? I multiply by negative 12.4. That's how we're going to get that negative value to become positive, which makes sense. We're not going back in time. So negative whatever times 12.4, negative 12.4. We get t to be 5.146 years. It takes 5.146 years for 25% of our sample of tritium to decompose. All right. That's not, can you handle that? We'll find out next week. All right, so exponential growth is initial, that stands for initial, times e raised to the, k is a constant, k is the percent of growth. A lot of times you see that with r. Didn't I teach you the continuous growth for money to be P-E-R-T because it said per? Same thing. So look at this real life situation. The rodent population in a city is currently estimated at 30,000. If it is expected to double every 5 years, when will the population reach 1 million? Okay. I'll walk you through it. I first need to find the K, the growth factor. I need to find K before I can answer the question. There's two. I got to find K before I can answer the question. What's the initial population of the rodents? 30,000. How long does it take for it to double? What is double of 30,000? So 60,000 equals 30,000 times e raised to the k, don't know it, and then how long, they gave me this value of t. How many years does it take from 30,000 to get to 60,000? 5. So k times 5. Okay? All right, let's solve for k. Let's divide by 30,000. I think we can do this without a calculator. I can do this one, Ella. I got it. Ready? Boom, boom, boom. 6 divided by 3, 2. Okay, E raised to the, can I call it 5K instead of K times 5? That makes me uncomfortable. Okay? Anybody else feel uncomfortable when you put a variable before the number? Okay. All right. I can't solve an exponential. Rewrite it in log. So, log base C. What should I write? What's log base C? ln of 2 equals 5K. Pick up your calculators. Pick up your calculators. K is the natural log of 2 divided by 5. Would you agree with that? I lied. Don't pick up your calculators. I don't care. We're not rounding. We're not rounding yet. Because that's what K is. K is the natural log of 2 divided by 5. I am going to say what it is. The natural log of 2 divided by 5. So it's holy crap, it's 13.863%. That's a pretty significant growth, okay? But we're going to leave it like that because you have to round, and we're not going to round, so we're just going to call it that. K is ln 2. Now, what's the question asked? When will the population reach? Okay, what was the initial population of our rodents? 30,000. Apparently they don't. This city does not believe in exterminators, right? Or mouse traps, or whatever. It's like one of those cities of, I don't know. It's a safe haven for rodents. There you go. It's a safe haven for rodents. So 30,000 times E. What's K?
0.13 squiggle.
No. K's what?
13.
No, natural log of 2 over 5. No, we're not even going to write it this time. We don't round. I know you're not. I'm going to write it like that. Times T, I don't know how long, Caitlin. And then what are we trying to get to? Equals what? What was it? 1 million. Like, it sounds like horrible. I hate rats. Anybody else hate rats? Like, I don't like snakes. I can kill them. Rats give me the heebie-jeebies. I remember, hey, obviously it like went up his Carhartt leg to his jeans, but still, no way. All right, anyways, ready? What do we do? How do we solve for T? What do we do?
5 million.
Divide by what? 30,000. Thank you. Not all. You guys all said at the same time and like muted each other out. Okay. Boom, 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 boom. 100 divided by 3. I'm going to leave it 100 divided by 3. It's 33.3 repeating, right? I'm going to leave it 100 over 3. Equals E raised to the natural log of 2 over 5 raised to the T power. Now, be careful here. You can't just, you got to rewrite it. You follow me? You got to rewrite it, and then it'll make sense. Can't solve it in exponential, do what? Rewrite it in log. So you're going to write what? Log base C, which becomes ln of 100 over 3 equals exponent. Natural log of 2 times T. See, that's not be careful here. That's not ln of 2/5. Then you could have dropped them like it's hot. That's the natural log of 2 divided by 5. You all follow me on that? So here's what you're going to do. Ready? Take your calculators out. Let's take natural log of 100 divided by 3. You guys all have that written down so I can go to my calculator. So we're going to take we're going to find the natural log of 100 divided by 3. Get that right. And then we're going to divide it by, what do we have to divide it by? The the natural log of what? 2 over 5. So it would look like this, divided by the natural log of 2, better close that parenthesis, divided by 5. It's going to take 25.294 years. Or never, because we're going to kill them all. Did everybody else get that? Did I do my math right? Excuse me. Okay. So, our homework assignment is that, and what, guys? Finish WebAssign.